cryogenic milling operation is very similar to a normal ambient grinding operation, but it will be exposed to very low temperatures and needs to be designed for that environment. It will also contain some additional equipment to handle the liquid nitrogen. It can be set up in many different ways, but the basic components may include a mill, a cryogenic conveyor, liquid nitrogen flow controls, a liquid nitrogen supply system, and then other supporting equipment common to normal ambient grinding operations. Mill selection is very important. It's best to determine the mill specifications empirically rather than through theory or calculation. Materials of construction are also a key factor for safe operation due to the very low temperature of liquid nitrogen. It's a good practice to pre-cool the material before it enters the mill. The cryogenic conveyor is where your material is introduced to the liquid nitrogen to do this. There are multiple options for conveyors, including screw type or tunnel type, and foam or vacuum insulated. There are multiple ways you can set up the liquid nitrogen flow controls. Usually the preferred method is to control the liquid nitrogen flow based on a set temperature at the mill output. The temperature feedback is provided by the addition of a thermocouple at the mill outlet. A liquid nitrogen supply system includes an insulated cryogenic tank to receive deliveries and store the product until needed. An insulated house line would also be needed to transfer the liquid nitrogen from the tank to the processing equipment with as little heat loss as possible. Additional upstream and downstream bulk handling equipment are also common to regular ambient grinding operations and may consist of a feed system, conveyors, airlocks, cyclones, particle size separation, oversized material recycle loop back to the feed system, finished product collection, and a bag house or filter. Specifying the correct equipment for a successful cryogenic milling operation would require consideration of several parameters. Some of those parameters include the material properties, such as density and embrittlement temperature, the feed particle size, the desired processing rate, the desired particle size, and the desired particle shape. As you can see, there are several things to consider. Experts at Air Products like myself can review your requirements and help determine the system that would best fit your needs.